Yes, very good morning to all of you. Myself, Mahesh Jagdish Pingre, lecturer Electronics Engineering, Government Polytechnic Ambad. So, dear students, today we are going to discuss a new concept of antenna that is called as the isotropic antenna. So, we exactly must know what exactly we mean by the isotropic antenna. So, first of all, we must know that isotropic antenna, it is a hypothetical antenna. So that particular antenna never exists in reality. So this particular isotropic antenna, it is an ideal antenna. So it is treated as an ideal antenna for every kind of specifications. While defining the isotropic antenna, we say that isotropic antenna or isotropic radiator is a point source which can radiates equally in all directions. So suppose this particular dot here in this diagram, if this particular dot or the center is act as an isotropic radiator, then this particular antenna or the isotropic radiator radiates energy equally or uniformly in all direction. So whatever the energy we are receiving here, the same amount of energy we can receive here, the same amount of energy we can receive here. So for every point on this particular sphere, we are having or we are getting the same kind of power or same kind of energy. So that's why we say that isotropic radiator is a point source antenna which radiates equally in all directions. Now, as shown in figure, we observe that the isotropic radiator is radiating electromagnetic waves equally in all directions. So, isotropic radiator, it is also called as a fictitious source. Fictitious source means it is a hypothetical source. It never exists in reality. Now, whatever you are observing, it is not a circle, it is a sphere. So, it is a 3D structure. So, just like a ball. So, at every point on the surface of this particular sphere, we are observing the same amount of power that is transmitted from your antenna. So, it is an ideal case. So, we say that an isotropic radiator produces a spherical wavefront of radius r, and all the points at a distance r from the source lie on the surface of the sphere and have equal power densities. I will repeat once again. An isotropic radiator produces a spherical wavefront of radius r, and all the points at a distance r from the source lie on the surface of the sphere will have a equal power density. So the power density measured at any point on this particular sphere from this particular distance r from the center of this particular sphere, we have same amount of power density. So electromagnetic waves spread uniformly in all direction in the space. So the radiation pattern of the radiator sphere is as shown in this particular figure. So these kind of isotropic radiators are always used for studying the radiation patterns for judging, comparing performance of the real life antennas. Now what we say that suppose I have designed one antenna. Suppose this particular antenna I have designed, suppose X antenna I have designed, and I want to check the performance of this real life antenna. Real life antenna means it is actually present here. So we have already designed it. Now when I want to observe the performance of this particular real life antenna, I will check whatever the parameters or the performance of this particular real life antenna with the isotropic antenna and compare, yes, whether this particular real life antenna, it will work exactly as the isotropic antenna or nearby to the isotropic antenna. So if I am getting results approximately similar to the isotropic antenna, then this particular real life antenna, it is used for the electronic application. So this is all about the isotropic antenna. I will once again the concept of the isotropic antenna. Isotropic antenna is a hypothetical antenna. It is not exist in real life. it is a fictitious antenna, and the concept of isotropic antenna that it will radiate energy equally in all directions in spherical manner. So if we measure the power density at each point of this particular sphere, we are getting same kind of power density for each and every point at a distance r from this particular center place where we have placed this isotropic radiator. So I think it is clear to all of you. So thank you very much.